For more updates, click on subscribe and click on bell button for latest notifications.
To get started, we need the execution environment. On python.org, you can find the standalone installer for the latest version, 3.14.7. In languages like C++ or Java, you must specify exactly what kind of data each variable holds, like an integer, float, or string, before the program even starts. Python removes this initial hurdle through dynamic typing. You simply assign the value, like x equals 10, and the system determines the data type automatically during runtime. It looks at the content first, then assigns the classification. This raises a technical question. If we aren't the ones defining these types, what is the internal logic Python uses to interpret the numbers we type into it? We can see this logic in action by opening the Python idle shell, the interactive environment where we talk directly to the interpreter. While Python supports 14 different data types, they all branch off from these 5 fundamental building blocks: integers, floats, booleans, complex numbers, and strings. When you input a whole number, Python's first instinct is to treat it as a standard base 10 decimal. However, since hardware operates in binary, or base 2, Python allows you to write in that format directly. By adding a 0b prefix, you tell the system to ignore the decimal default and read the input as raw machine logic. This binary bridge is strict. Binary only recognizes zeros and ones, so if you attempt to use any other digit, like a 2, the system immediately triggers a syntax error. These rules ensure that even the most abstract human concepts are translated into literal instructions the processor can understand. Python supports other counting systems, like octal or base 8, accessed by prefixing data with 0 and O. For more complex values, hexadecimal, or base 16, uses digits 0 through 9 and letters A through F to represent large binary values using shorter character strings. Behind the scenes, converting these values requires manual division and tracking remainders to move between bases. Python automates this through built-in functions like bin, oct, and hex, which handle those conversions for you instantly. When you move from whole numbers to fractional data, the system switches to the float data type. For extremely large or small numbers, floats can use scientific notation. This exponential form allows the computer to store massive values using significantly less space in memory. Learning these specific formats gives you more direct control over how the system interprets your numerical data and handles memory-heavy structures. To understand why this matters, we have to look at what's happening inside your RAM.
It's common to imagine a variable as a labeled box with a number inside it, but in Python, that isn't quite right. If you run the id command on a variable, Python returns a massive string of digits. This is the literal physical address of where that data is living in your computer's memory. In Python, everything is an object. The value 10 is created as its own independent entity that sits in a specific memory cell. The variable x is actually just a pointer, a lightweight signpost telling the system where to find that object. This pointer-based system is exactly what makes dynamic typing possible. Because the name is separate from the data, Python can simply move that pointer to a different object whenever the value changes, without needing you to stop and reclassify the variable itself.
Please follow us on social networking sites. One is Facebook. The Facebook page name is @linuxarkit. You can click on this button here and click like page so that you can follow us on Facebook. The next one is Instagram. Instagram page name is arkit.co.in. Click on follow button to follow me. And Twitter, if you have any questions on subject line, or if you have anything, you can just tweet me at @ravikumar48, so I will reply you most on the tweet back. For anything related, if you want the latest articles on my website, so here is my website details and email address details. You can reach me over here.